Hello dear students, we find so many quantities around us which can be measured, like we can measure time, temperature, velocity, speed, displacement. So all these things can be measured, and these measurable quantities are called physical quantities. And you see, some of these physical quantities have magnitude only, value only. They don't have direction. For example, when we say a time of 1 hour, it means the value only, it gives us the value only. This time of 1 hour has no direction. Similarly, length, area, speed, all these things do not have direction, they have magnitude only, and they are called scalar quantities. On the other hand, there are some physical quantities which have both magnitude and direction. For instance, weight. Our weight is directed vertically downward. So, weight has some value and it has direction also. Likewise, force, acceleration, velocity, these things have both magnitude and direction, and hence they are called vector quantities. So today in the class we are going to discuss in detail about vectors. So you see, vectors are those quantities which have both magnitude and direction. Now let's take one example of electric current flowing through a wire. Let's say this is the point A and this is the point B of the wire, and a current of, let's say, 2 ampere is flowing from A to B. So what is the magnitude of the current? It's 2 ampere. And where is it directed? It is directed from A to B. That's it's flowing from A to B. It has direction, isn't it? But this is not a vector quantity. An electric current is not a vector quantity. This is because for a quantity to be a vector quantity, it has to fulfill actually 3 characteristic features. It has to have magnitude, direction, and the third and the important point is it must follow vector rule of addition. That will take later on. Types of vectors. Now there are different types of vectors, okay, like the vectors lying on the board. All those vectors, they all lie on the board. That's why they are called coplanar vectors. Now let's take another example of vectors. Now vectors A, B, C and D, they all lie on the same straight line, isn't it? So since they all lie on the same straight line, they are called collinear vectors. Now let's take another one. Now here you see vector A, B, C and D. They all start or originate from the same point. That's why they are called co-initial vectors. Now, in this example, you see all those vectors, they terminate at the same point, isn't it? That's why these vectors are called co-terminal vectors. Now we have come to another very important type of vector, okay? So let's see here. Let's say force, it's a vector quantity, isn't it? And if I say a force of 1 dyne or 1 Newton, or displacement, you know displacement is a vector quantity. So displacement of 1 meter, okay? So in these cases you see these vectors have unit value, isn't it? these vectors are called unit vectors. So unit vectors are vectors having unit or one magnitude. That's all. You know the term displacement. Displacement is a vector quantity, isn't it? And it is the linear distance from the initial to the final position of the body, isn't it? So let's say a body starts from the point A and takes this path to reach the point B. So this much path traveled is called the distance, isn't it? But the linear distance, okay, the straight line, okay, this linear distance from the initial to the final position of the body, this is called the displacement. Okay, so you see this displacement has certain value and it has got direction from initial to final, isn't it? So this is displacement. Let's take this example. A body starts from the point A and after traveling some distance it comes back to the same point. Okay, starts from the point A and comes back to the same point A. So what is the displacement here? In this case, this is the same initial point and this is the final point. So from the same point to the same point, what is the distance? That is 0, and hence in this case the displacement is 0. So what kind of quantity is displacement? It's a vector quantity, isn't it? So a vector quantity having 0 magnitude is called 0 or null vector. So this way some of important types of vectors, and you see vectors can be added, vectors can be subtracted, vectors can be multiplied, and vector can be divided also. Okay, so we'll take them one by one. So first we'll take the addition of vectors. There you see an object A lying on a horizontal floor. A force of 5 Newton is applied to drag the body towards your right with the help of a thread. Let's say another force of 7 Newton is applied in the same direction, that means on the thread towards your right, okay, to pull the object. So what will be the total force applied on the body A? It will be simply sum of 5 and 7, isn't it? That means 12 Newton. Now take another case. Let's say this body B is pulled towards your right by a force of 5 Newton and it is pulled towards your left by applying a force of 7 Newton on the same straight line with the help of 2 different threads. Okay, so then where will that object move? Towards your left or towards your right? The object will definitely move towards the greater force, isn't it? So the object will move towards your left. And what will be the total force on the body? Now in this case the forces are in opposite direction, isn't it? That's why when the forces are in opposite direction we have to find their difference. That's why the total force in this case is 7 minus 5, that is 2 Newton, and that 2 Newton is directed towards your left. So isn't it very simple to find out the sum of vectors? But the problem arises, okay, when the two forces are not along the same straight line. Okay, for instance, the body C is pulled towards your right, or let's say towards east, okay, by a force of 5 Newton, and it is from the same point it is pulled towards northeast by applying a force of 7 Newton. So what will be the total force in this particular case? Now here, since the forces are not along the same straight line, we cannot add or subtract, isn't it? So there comes the need of the laws. Okay, actually there are two important laws by which we can find out the resultant vector. Now, the first one is, now to understand this triangle law, we take the help of displacement, because you know displacement is also a vector. Let a particle start moving from the point A and reach the point B after traveling some distance. Hence, in this case, the displacement is AB. Now, from the point B, the particle moves and reaches the point C after traveling some distance. So, what is the new displacement here? The displacement is AC. That means when the displacement AB and the displacement BC are added, they produce the total displacement AC. And see the direction also. It is not from C to A, it is from A to C. That is because, you know, displacement is measured from the initial position to the final position. Hence, if we take those displacements as vectors, so we can say that when the vectors AB and BC are added, they produce the resultant vector AC. Okay, let's take one more example. Let the vector P and Q act from the same point O. Now, to find out the resultant vector for P and Q, we do the same thing as we did before. First, we draw the vector P from A to B, and then from the point B, we draw the vector Q, that is from B to C. And as the rule goes, the displacement, the final displacement is given by the line joining the initial and the final position, isn't it? That's why the final vector, that means the resultant vector, is given by the straight line joining A and C. So AC gives the resultant vector in this case. This is the triangle law. So how do you then state triangle law? Triangle law states that if two vectors acting from the same point be represented in magnitude and direction by the two sides of a triangle taken in order, then the third side in the reverse order represents the resultant vector in magnitude and direction. Now let's have one more example where vector A, it is represented by this, okay? This sign with this sign represents vector A. Now vector A starts from this point O, and B, vector B is, let's say, started from the same point, is directed this way. Now when we have to add these two, we follow the same rule. First we take one vector. Now this vector A is in this direction, isn't it? So this is the direction of vector A. And from the terminal point, okay, from the end of vector A, we draw vector B. So B is in this direction. No? B, vector B. So according to that rule, okay, to find the final displacement, what we do, we join the initial and the final position, isn't it? So this line, okay, in this direction will give you the final or the resultant vector. It means that when vectors A and B are added, it produces the resultant vector in this direction. That means in this direction, isn't it? That means, so when A and B are added, the resultant vector will be directed this way. So this is your triangle law. So according to triangle law, when the vectors A and B are added, we get a resultant vector. Okay, let that resultant vector be R. Okay, so vectorially we can write vector A plus vector B is equal to R. Okay, now this is a vectorial relation only. It's simply representation only. Okay, it means that when these two are added, we get R, but this is not the algebraic formula. So now we are going to find the algebraic formula for the resultant vector. That means the magnitude of R. Now to find out the resultant vector using triangle law, we do this. Let this line AB, okay, represent vector A in this direction. Okay, from the point B, we draw BC, okay, and let BC represent vector B. So this is vector B. All right, and you know the distance or the line joining the initial and the final position, or you can say the third side of the triangle ABC in the reverse order, means in this direction, represents the resultant vector. All right, now with the help of this triangle, now we are going to find the magnitude of R. Okay, now to do that, we have to apply Pythagoras theorem, and you know Pythagoras theorem can be applied only to a right-angled triangle. And since we don't have a right-angled triangle out there, what we do is this. We produce the line AB. Okay, we produce the line AB, and from the point C, we drop a perpendicular on this produced line at the point D. Okay, so this triangle ACD, it's a right-angled triangle. So here we apply Pythagoras theorem to find out the value of this resultant vector. Now let's mark the angles also. Here theta is the angle between A and B, isn't it? Or you can say it is the angle between the direction of A and direction of B, isn't it? So where is A here? Okay, A is here, isn't it? Here means it is directed this way, isn't it? And where is B? B is directed this way. Since A is here, B is here, so this angle is theta. So this angle is theta. All right, and let this angle be a new angle phi. Okay, and this phi will give us the direction of the resultant vector. That we'll take later on. All right. You know, perpendicular square plus base square is hypotenuse square, isn't it? So this is the normal way of writing Pythagoras theorem, mathematical form of Pythagoras theorem. Now in this case, I'll reverse the direction. Okay, so we can write perpendicular square plus base square equals to hypotenuse square. The reason, very simple. If you do like this, okay, the deduction becomes very easy. Now let's put the values of perpendicular, base and hypotenuse. Okay, now which is the perpendicular out there in triangle ACD? The hypotenuse, it is AC. So I'll not write the value, I'll write the name AC square. Now base means AD, isn't it? So it is square of AD, and perpendicular you can see is CD. Now, do we have the value of AC? Yes, we have AC. So let me keep AC as AC because we have the value. Okay. Now, what about AD? AD. AD, you can see, is the sum of AB and BD, isn't it? That's why it is the sum of AB and BD, square of this and CD square. This we have, no? Now, let's expand it using the formula A plus B whole square, and that's equal to A square plus 2A B plus B square. Now, the leftover is CD square. All right? Now, let's put the values now. AC, what is the magnitude of AC? AC is R. So, it is R square equals to, now what is the magnitude of AB here? AB means A, isn't it? A square plus 2 into AB is A into now BD. We don't have the value of BD. Now that can be done in two ways. Okay. For that you need a little bit of trigonometry. All right. Now what we do is, and BD lies in this triangle, isn't it? No? And in this particular triangle, which is the side for which we know the value? This is BC. The value of BC is B, no? And which side is this in this particular triangle? This is hypotenuse. And this is base, isn't it? So, base by hypotenuse, what is that equal to? That is cos theta. So, in triangle BCD, base means BD, hypotenuse means BC. So base by hypotenuse is cos, and the angle out here is theta. That's why when you cross multiply, you get this. BD equals to this into this, which is BC into cos theta. No? And what is the value of BC? BC, it is B cos theta. That's why the value of BD is how much? It is B cos theta. Now, I will put these two together within a bracket. Why? The reason is this. BD. Now this BD, side BD, where is BD? BD, this is BD, isn't it? And where is CD? This is CD, isn't it? So BD and CD, okay, they belong to this triangle, not to the larger triangle, isn't it? They belong to this triangle. And for this triangle, what is BD? It is the base. And what is CD? CD is the perpendicular. That's why, what is perpendicular square plus base square? It's hypotenuse square, isn't it? And which is the hypotenuse? It is BC. Okay? So, here BD square plus CD square means BD for this triangle is base and CD is hypotenuse. That's a perpendicular square. So perpendicular square plus base square is hypotenuse square. Alright. So R square equals to A square plus 2AB cos theta plus, now BC. What is the value of BC out there? That is B, isn't it? Now I prefer to write this as this. R square is equal to A square plus B square plus 2AB cos theta. So this gives magnitude of the resultant vector. So this is the formula for the magnitude of the resultant vector. Now look at this. Isn't it very similar to a well-known algebraic formula? A plus b whole square, a square plus b square plus 2ab. So the value of this depends on the values of a and b, isn't it? But you know, in this case, okay, the value of the resultant vector not only depends on the values of a and b, but also depends on the value of theta. Now let's take two important cases. Case 1, okay, when theta equals to 0 degree, that means 0 means a and b should be on the same direction, on the same line, isn't it? That in this case the angle will be 0. Now in this case, resultant will be a square plus b square plus 2ab cos, and the angle here is 0 degree. Now this is a square plus b square plus 2ab into, now what is the value of cos 0 degree? It is 1, no? So 2ab into 1 is 2ab. So r square is a square plus b square plus 2ab. And what is this equal to? Whole of this is equal to, you all know it is a plus b whole square. And here you can cancel the squares, and finally you have this a plus b. Okay, so what does it mean? When a and b are in the same direction, okay, in the same direction where its angle is 0, okay, in that case the total vector will be the sum of a and b. Okay, that's why this is the maximum value of the resultant vector. Now in the second case we are taking theta to be 180 degree. What does that mean? That means if vector A is in this direction, vector B is in opposite direction, so that the angle between these two is 180 degree. That means when the vector A and B are oppositely directed. Now let's find out r as we did before. R square is a square plus b square plus 2ab cos 180 degree. Now cos 180 degree is equal to minus 1. Okay, the value of cos 180 degree is minus 1. So when you multiply, you get this plus and minus, minus 2ab into 1 is 2ab. Now look at this formula. Isn't a square minus 2ab plus b square? And what's that equal to? A minus b whole square. So the square you can cancel. So the final resultant will be a minus b. Okay, that means when there are two vectors in opposite direction, okay, we find the difference to get the value of the resultant. And that was the point where I started from, no? And this is the minimum value of the resultant. Direction of r. Now I told you before also, no? The direction of r is given by the value of this angle phi. Okay, let's see how the value of this angle phi will tell us about the direction of r. Now when phi is equal to 0 degree, suppose in a sum, okay, sum is like such that, so sum is such that the value of phi is 0, then what we say from this? Now this is the direction of A. Now with respect to A, we have to find the direction of R, isn't it? Now what is the angle here? 0. Now the angle will be 0 only when R is also in the same direction as A, isn't it? So where is R, or the resultant vector, directed in this case? Along A. Okay, so that's given by theta equal to 0. Now we have, let's say, phi equal to 90 degree. Okay, first I need to draw A. So this is A. Now with respect to A, we measure the angle phi, isn't it? So what is the value here? 90. 90 means it should be directed like this, isn't it? So this is the direction of R, where this angle is 90 degree. So the value of phi, okay, actually gives the direction of R. Okay, and now we are going to find the expression that contains phi. For this also, I'll use the same right angle triangle ACD. So I will take tan phi. Now you know tan theta is perpendicular by base, isn't it? Turn permanently black, isn't it? Now in this particular triangle, that means ACD, which is the perpendicular? This is the perpendicular, CD, isn't it? CD. Okay? And which is the base? Base is AD. This is AD. Now tan phi is equal to, let's try to put the values of CD and AD. Now CD, where is CD? Here you have CD, and what's the value of CD? There is no value of CD. And what is AD equal to? AD also has no proper value as such, isn't it? Now in the previous case, I told you how to convert an unknown into known, isn't it? Taking the help of that cos theta, isn't it? Now here I will tell you another way, okay, to convert unknown to known. So this is how it is done. Okay, first let's break this AD, okay? AD is the sum of AB and BD, isn't it? So it is the sum of AB and BD. Now this is unknown quantity because we don't have the value of this CD. But which side in this particular triangle has the value? That is BC. That in BC for us is known, isn't it? The value of that is B. So what we do is, to convert this unknown into known, we multiply it by a known value. A known value in that particular triangle closer to that side is BC, no? So what I'm doing is I'm multiplying this CD by BC. But you know, we can't do like this, isn't it? It has to be balanced also, isn't it? That's why in order to cancel or to balance it, we have divided by the same quantity BC. So BC gets cancelled, you get CD back, isn't it? Now AB, but is the value of AB given? Yes, we know the value of AB, that is A. That's why I will keep AB as AB because we know the value. BD. BD is this side, this is unknown, isn't it? And which is the side known here in this triangle? Again, BC. And the rule, to convert this unknown into known, we multiply by the known value BC and again divide the same by BC. Okay, let's see how, let's see what we get here. Tan phi is now BC. What's the value of BC out there? Value, okay, it is B into CD by BC. Let's see what is this CD by BC. Now CD for this triangle, CD for this triangle is the perpendicular, no? This is the perpendicular. And BC, BC for this triangle is, BC is the hypotenuse, isn't it? And perpendicular by hypotenuse is sine, isn't it? Some people have, you know, isn't it? And the angle here is theta. That's why it is B sine theta. AB, what is the value of AB? It is A plus BC. BC is B, and now BD by BC. BD by BC. BD for this triangle is the base, and BC for the triangle is hypotenuse. And what is base by hypotenuse? It is cos, isn't it? Curly brown hair. And the angle out here is theta. That's why this is cos theta. So this gives us the direction of the resultant vector.